a simple Sun-Earth relationship, based upon an electrical universe model. The system can be looked at as a simple electric circuit, as shown here. In this model, only the Sun and Earth are in circuit. Theory versus electrical components. A solar unipolar magnetic field is shown as L1 and L2. Earth's magnetic field is shown as L3. C1 represents the capacitive nature of the magnetosphere. Red arrows indicate the direction of current flow. The coils are wound in accordance to Faraday's law. Values are only very rough guesstimates. In this model, the solar core is shown as the collector, or cathode of Q1. The photosphere is shown as the drain of Q1. The feedback current is shown as the base of Q1. Q1 would collect current from the interplanetary magnetic field, and from the looping back of the Sun's own field, at its equator. Based on feedback at the base of Q1, the varying output is seen on the emitter of Q1. The feedback will vary, in turn, changing Q1's output. So there seems to be some current regulation occurring here. Currents flow from the solar north and south poles outward, and back to the equatorial regions on the Sunday. This can also represent the heliosphere. Earth is shown as L3 and C1, in simplest of terms. L3 produces a magnetic field directly proportional to the emitter of Q1, also known as the Earth footprint, or magnetic connection to the Sun, via Earth's North Pole. Earth's South Pole is connected to the interplanetary magnetic field, or IMF. This, in turn, feeds back into the collector of Q1. Hence, as long as there are currents and electromagnetic fields, Q1 has a potentially unlimited power source. No nuclear process is required. The source and output is regulated by the feedback on the base. It is, truly, a totally interconnected system, with all components sustaining the others. Solar output and Earth's magnetic fields would necessarily vary in strength, depending on Q1's collector, or IMF, and currents returning to the base of Q1. In this sense, a discharging of C1 feeds the collector of Q1. In the same manner, solar output would also vary depending on both the IMF strength and the feedback on the base of Q1. This could be viewed as varying solar activity, which would most likely be cyclic in nature, as well as the magnetic field of Earth, and all other celestial bodies. Next, we can begin to include other planetary bodies. I will only add bodies that would have a significant impact on the whole circuit, or planetary bodies with magnetic fields of their own. We can start with the planet Jupiter, which besides the Sun, has the strongest magnetic field of all other planets. We can use L4, C2, and R2 to represent Jupiter in circuit. The resistors have been added to account for the resistive properties of those bodies, which all have inductive, capacitive, and resistive qualities. The time domain current and voltage plots are measured from the emitter of Q1, and the simulated south poles of both Earth and Jupiter. By adding Jupiter as a circuit, we see the entire circuit become even more highly regulated. This may be hard to see, as the component values being used are producing an extremely tiny microclimate of geospace. The source seems to remain steady and the voltage plot shows cycles of highs and lows over time. It now looks as if the planets themselves act as regulators for Q1. I would guess that adding a few more planetary bodies would result in even better voltage regulation in this circuit. In the next episode, we will try adding the planets Venus and Saturn, both of which have dramatically different electrical properties.